సబ్స్క్రైబ్ చేయండి. ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి.
Now we are going to discuss dielectric materials. What is the dielectric? General dielectric means dielectric materials are insulators. Dielectric materials are insulators. General term is the insulators. Insulator means there is no conduction. There is no conduction. Okay. The general term, what is the conduction? Conduction means electrical conduction or thermal conduction. What is the conduction? Conduction means allow the flow. Allow the flow. Allow the flow of electrons. Electrical conduction. Allow the flow of thermal energy. Thermal conduction. Here the word dielectric is equals to insulators. Insulator means no conduction. No conduction. That means there is no free electrons. There is no free electron. For example, this is the material. This is the material. In this material there is no free electrons. There is no free electrons. That means it is not possible for the electrons in the valence bond. It is not possible for the electrons in the valence bond. Okay, so that means there is no free electrons. అంటే ఇక్కడ ఫ్రీ ఎలక్ట్రాన్స్ ఉండవు. ఫ్రీ ఎలక్ట్రాన్స్ ఉంటేనే ఎలక్ట్రిసిటీ ఫ్లో అవుతూ ఉంటుంది. సో the word dielectric means insulators. The general meaning of the insulator means no conductions. No conduction means it is not possible for the electrons in the valence bond. Valence bond. That means the dielectric materials also called as insulators. Insulators. In dielectric materials, all the electrons are tightly bound. Tightly bond. Tightly bond means there is no free electrons. There is no free electrons. So this is the tightly bond. This is the tightly bond. So here free electrons. So if there are free electrons in material, the material behave as conductors, but there is no free electrons. There is no free electrons. That means tightly bound their molecules. The electrons tightly bound their molecules. Therefore there are no free charges. There are no free charges. No free charges. So that means the forbidden gap is more than the forbidden gap is more than 3 electron volts. 3 electron volts. Therefore it is not possible for the electrons in the valence bond. So there is no conduction. There is no conduction. That means dielectric materials. So from one by one, the dielectric materials are also called as insulators. What is the insulators? Insulators means the dielectric in dielectric materials, all the electrons are tightly bound to molecules. If the electrons are tightly bound, there is no free electrons. That means there is no free charges. So if there is no free charge, the forbidden gap is more than 3 electron volts. So if the forbidden gap is more than 3 electron volts, it is not possible for the electrons in the valence bond. Okay, if it is not possible for the electrons in the valency bond, that is no conduction, no conductivity. If the materials are behave as no conduction, that means dielectric materials. That means dielectric materials. So the dielectric materials are two types. The two types are, one is the active dielectric materials, second one is the passive dielectric materials. So active dielectrics and passive dielectrics. Active is the word meaning is activeness. That means some allowed to electricity. Some allowed to electricity. So just like as conductors. Just like as conductors. Just means just. Not purely conductors. So here passive means opposite to active. Opposite to active. So it's purely insulators. It's purely insulators. So these are also insulators, but we applied external electric field or external magnetic field, then the materials are behave as conductors. These two materials are also insulators, but active dielectric materials are insulators, but if we applied the magnetic field, then the materials are behave as conductors. So that means active dielectrics. Active dielectrics. So these are all purely insulators. Purely insulators. Active dielectric materials are, that means active dielectrics are the dielectrics which can easily adapt themselves to store the electrical energy. So active dielectric materials are also dielectrics, but the active dielectric materials kept in external magnetic field. Let us consider this is the dielectric material. This active material is kept in external magnetic field. External magnetic field. Then in the material produce the free electrons. Produce the free electrons. Then it actively accepts the electricity. It actively accepts the electricity. Then it is known as active dielectric material. That means active dielectrics are the dielectrics which can easily adapt themselves to store the electrical energy. That are all active dielectrics. It means, for example, we know that piezoelectric. Piezo means pressure. We applied the pressure on the any dielectric material, then the electricity is produced. Already we know that it is the any crystal or any material. We applied the magnetic field. We applied the magnetic field on one side, and the another side the electrical field is produced. That is the piezoelectric materials. Piezoelectric materials. This piezoelectric effect is in our first semester physics. Piezoelectric effect. Any material is kept in magnetic field, there is electric field is produced. That is the piezoelectric effect. And also piezoelectric materials and ferroelectric materials. Ferroelectric materials. That means ferromagnetism, ferroelectric materials. So these two are examples of active dielectrics. Active dielectrics. Second classification is the passive dielectrics. That means same as passive dielectrics are dielectrics which restrict the restrict the flow of electrical energy. So in the active dielectrics accepts the flow of electrical energy. In this passive dielectrics restrict the flow of electrical energy. And a flow of electrical energy allow cheyadamata. Does not allow the flow of electrical energy is the passive dielectrics. Allow the flow of electrical energy is the passive dielectrics. So this is the passive. So restrict, that is also does not allow. So does not allow the flow of electrical energy. The dielectrics are called as passive dielectrics. So the passive dielectrics acts as insulators. For example, all insulating materials such as mica, rubber glass, and also PVC materials, ceramics, these are all insulating materials. These insulating materials are solid insulating materials, same as liquid insulating materials. Liquid insulating material means mineral insulating oils, synthetic insulating oils, miscellaneous insulating oils. These are all liquid passive dielectrics. And also gaseous insulating materials, gaseous insulating materials, that is nitrogen, sulfur hexafluoride. These are all gaseous passive dielectrics. So passive dielectrics examples are three types. One is the solid insulating materials, second one is the liquid insulating materials, third one is the gaseous insulating materials. Solid insulating materials are mica, rubber, glass, PVC materials and ceramics. These are all. Liquid insulating materials are mineral insulating oils, synthetic insulating oils, miscellaneous insulating oils. The gaseous insulating materials are nitrogen, sulfur hexafluoride. These are all gaseous passive dielectrics. Applications of dielectric materials. Generally, the dielectric materials are used in capacitors. The dielectric materials are used in capacitors to store electrical energy. Capacitor to store electrical energy. The dielectric materials are used in capacitors to store electrical energy. So that store electrical energy depending upon types of dielectric material. So the capacitor may be grouped into the different types of dielectric materials. Once again, the dielectric materials are used in capacitors to store electrical energy. The store electrical energy depending upon the types of dielectrics used. So types of dielectricals used: air, gases. These are all gaseous insulating materials. Mineral oil, this is also liquid insulating materials. So combination of solid means solid is also in solid insulating material. These are liquid insulating materials. Capacitors with only a solid dielectric. So these are all different types of dielectric materials are used in capacitors because the capacitors to store electrical energy. So the store electrical energy depending upon the types of dielectrics are used. So first of all, The capacitors which uses vacuum, air, gases as dielectric. అంటే కొన్ని కెపాసిటర్స్లో ఎయిర్, గ్యాసెస్, వాక్యూమ్ని యూజ్ చేస్తాము. ఇవి ఏ టైప్ ఆఫ్ మెటీరియల్స్? గ్యాసియస్ ఇన్సులేటింగ్ మెటీరియల్స్. గ్యాసియస్ ఇన్సులేటింగ్ మెటీరియల్స్. సో నెక్స్ట్ పాయింట్, కెపాసిటర్స్ ఇన్ విచ్ ద డైఎలక్ట్రిక్ ఈజ్ ఏ మినరల్ ఆయిల్. అంటే కెపాసిటర్స్లో మనము మినరల్ ఆయిల్ మీన్స్ లిక్విడ్ ఇన్సులేటింగ్ మెటీరియల్స్ని కూడా యూజ్ చేస్తాము. నెక్స్ట్, కెపాసిటర్స్ ఇన్ విచ్ ఏ కాంబినేషన్ ఆఫ్ సాలిడ్ అండ్ లిక్విడ్ డైఎలక్ట్రిక్స్. ఆల్రెడీ వి నో దట్ insulating solid materials, insulating liquid materials. So capacitors with only a solid dielectrics. అంటే మనకి dielectric materials are insulating materials are three types. First one is the solid insulating materials, second one is the liquid insulating materials, third one is the gaseous insulating materials. These three type of dielectric materials are used in capacitors. So capacitors are to store electrical energy. So the stored electrical energy depending upon the types of dielectric used. Properties of dielectric materials. Main property of the dielectric material is the insulation resistance. Insulation means there is no conductivity. Resistance means oppose of flow of the current. So main property of dielectric material is the insulation resistance. The main reason of the failure of any electric equipment, the insulation is failure. The main reason of the failure of any electric equipment, the insulation failure. The major function of the insulation resistance is to be prevent the flow of electricity through it, and at the same time it must conduct the heat generated inside. So that means the main reason of the failure of any electric equipment, the insulation failure. The main reason is the insulation failure. The major function of the insulation resistance is to be prevent the flow of electricity. So these insulation resistance is two types. First one is the volume resistance, second one is the surface resistance. The volume resistance is the resistance offered to the current which flows straight through the volume. The volume resistance is the resistance offered to the current which flows straight through the volume of the dielectric material. So once again, the volume resistance is the resistance offered to the current which flows straight through the volume of dielectric material. Surface resistance is the resistance offered to the current which flows over the surface of the dielectric material.